Hey guys, welcome back to AlgoYogi. Now we are doing array and hashing series, and our next problem in the list is contains duplicate. So it's a really easy problem, but because it's part of our series, so let's just get done with this. Given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. So basically we need to return if there is a duplicate value. So here I have taken the first example. Well, we just need to check if each element is distinct, right? So how about, so let's go over the brute force approach. In our brute force approach, what we can do is for each element, let's say I, we will try to find a jth element in the remaining array, such that if the element that I is pointing to is seen in the remaining array, then we will return true, because that means that is the duplicate. Otherwise we will return false. So what we'll do for our brute force, I can just simply write the pseudocode here. So we'll have two for loops. So let's say for I in range n, and n is basically the length of nums, right? And for j in range, we can check it in the remaining values. So I plus 1, we can start our pointer and then go up to n. And if nums at I is equals to nums j, that means we will return false. We will return true. I mean, because you are seeing a duplicate value. That was the ask of the problem. So what will happen is we will return true, right? So we will return true. Otherwise we will return false here. Return false. My bad. Return false. Well, that will be the entire solution. Now, the time complexity of this solution is big O of n, and space complexity is big O of 1. Now in today's scenario, where it's so easy to make like a lot of memory, where NVIDIA is making like these massive chips, these the industry of memory making has gone to supreme. It has become supreme. So in today's scenario, it's not so important to introduce a little bit of space complexity, but we need to bring down this time complexity, which is n square in this case. My bad, I wrote big of n. So this is n square. We need to bring it down to n, because n is considered like a really decent time complexity. So how about we introduce some of the space and bring our time complexity to n, and make make our solution a little more efficient. So what we'll do is we'll have a set called scene values, and it will be just a simple set. And for num in nums, if this num in our set, so in scene values, then we will return true, right? Because we are seeing a duplicate. Otherwise we'll add this num to scene values, our set. So scene values dot add, basically we are returning true if any value at least appears twice. Yes, so that's good, num, and otherwise we will return false, right? That's the entire solution. So here this will have the time complexity of big O of n, and space complexity is also big O of n because of this guy right here. So it's easy simple problem. We were just doing it for the sake of doing it. I'm probably, not doing great, big of a deal by solving this problem here. Well, anyway, let's write it down. No problem is a small problem, because we can all fuck up, when in the interviews. So let's say if not nums, or length of this nums is basically equals to 0, then we will return false, because there are no duplicates, right? Otherwise, for num in nums, if this num in scene values, our set that we are going to declare, scene values is a set integer. So if this is in our scene values, then we return true. Otherwise we return false. But before that, let's add the value to our scene, all the values. So num in nums. So that is it. Let me zoom out. That was the entire solution. I will just submit it directly rather than testing it on example, because we are that confident, right? It's an easy problem. So time complexity is not dollar, it's big of n. So it's big of n, and space complexity is also big of n, because we have introduced it, right? Big of n. All right, so without wasting any time, let's go to AlgoYogi, mark this problem solved, and see you guys in the next problem. Until then, bye-bye.